Hey guys, it's Mr. C. Welcome back to Level 6 Math. Today we're looking at our Saxon Math Lesson 109 on corresponding parts and similar figures. So we're going to be looking at different angles and sides today. On these two triangles, we see that they're congruent. What that means is that each triangle has three angles and three sides. And they correspond, the angles and sides on this triangle correspond to the angles and sides on this. That means they're the same. So we can see that the angles are exactly the same and the length of the sides are exactly the same. The difference is that they're rotated, right? So they don't match up exactly. But if we rotate, transfer, and reflect ABC, this triangle, we're going to come up with this one. So we'll see that angle A corresponds to angle X. Angle B corresponds to angle Y, and the one here with the right angle, angle C, corresponds with angle Z. We can also see that the sides all correspond. So AB corresponds to XY, BC corresponds to YZ, etc. So it's the exact same triangle, it's just rotated and reflected. All right? So here we see that they have the same shape. All of these triangles, well, not all of them. You'll see that three of the four have exactly the same shape. Two are the same size. So we would say these 1 and 2 are congruent. But 1, 2, and then 3 are similar in that they have the same angles, but the sides are longer. So the scale has changed. Now, the triangle 4, it's not similar or congruent with the others. So we have to pay attention to those. We can figure that out. Are they congruent if the angles are the exact same and the length of the sides are exactly the same? They're similar if just the angles are the same, but the length of the sides are different. So here we can see that these two are congruent. If they're congruent, then we know that each side is exactly the same. We just have to match them up. So if we want to know the perimeter, we've got two of the sides from this one and two different sides from this one. Well, this one's the same. 4 and 4 is the same. But if we rotate it, we'll see that this long side is 5 down here. So we know that the perimeter is 3 plus 4 plus 5. So 3 plus 4 is 7 plus 5 is 12. So if we match them up, then we can get all three sides marked in, add them up, 3 plus 4 plus 5, and we get 12 inches. So you're going to take two congruent triangles, find the missing side by analyzing them, and then you can get the perimeter. The two triangles here are similar. That means that the angles are the same, but the length of the sides are different. So that means if angle A is going to correspond probably with this one, but let's look at it. If we have to rotate it, so here we have the 90-degree angle is the same here, and then we see that one is bigger and one is smaller, so this one's bigger and this one's smaller. So that's probably going to be A right there, 30 degrees. And you can usually eyeball this, but if you need to, you can actually kind of rotate it and think through it and see how they match up. See how they've gone ahead and redrawn it so it was rotate, but they came up with the same answer, 30 degrees. Here's two important things about polygons. So the first thing, corresponding angles of similar polygons are congruent. So it's important to remember that. And second, the corresponding sides of similar polygons are proportional. It means that they stay the same. You just scale them up. The first fact means that even though the sides of similar polygons might have matching lengths, the angles don't have to necessarily match. The second fact shows that similar figures are related by a scale factor. So in that one, the scale factor is a number, and you can multiply the side by a length to give it the scale. And we're going to do that here on this next example problem. So here we have two polygons that are similar. That means the angles are exactly the same, but they're not congruent. So the sides are different. Here we see, so if all the angles are the same, we're going to have the same ratio for the scale. So by what scale factor is ABCD larger than EFGH? Well, we can see this side is 1 and this is 2. So that's double, right? This one's 2, this one's 4. So we can assume that this one's going to be 2 and this one's going to be 4. Well, all we have to do is take the scale from this one and put it over the scale for this one, So here we have side AB is 2, side EF is 1. So we have our scale or our ratio of 2 to 1. So we're going to increase this by a factor of 2. In all similar polygons, such as these two rectangles, the ratios of corresponding sides will be equal. Yep. All right, so here we have that it's 2 times larger, so it's scaled by a factor of 2, and that's it. So we're going to just practice on this assignment looking at similar versus congruent triangles and other polygons, and you might have to do a few scale problems. It'll be good practice for you. All right, see ya.